Preparing for a systems engineer interview. You've reached Candy Mentor, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. A Linux server is running slow. How would you troubleshoot it? I start by checking whether the issue is CPU, memory, disk, or network related. I use uptime, top, vmstat, iostat, free, df, and ss to narrow it down. Then I inspect logs in journal.ctl or /var log and check recent deployments or config changes. I avoid guessing. I compare current metrics with baseline behavior. Once I identify the bottleneck, I apply the smallest safe fix and monitor recovery. While answering, focus on a structured path: symptoms, recent changes, CPU, memory, disk I/O, network, logs, process level analysis, and how you confirm the actual bottleneck before changing anything. Question 2. What happens when a user types a URL in the browser and presses enter? The browser first checks cache, then resolves the domain through DNS to get an IP address. It opens a TCP connection, usually negotiates TLS, and sends an HTTP request. That request may pass through a CDN, load balancer, web server, application service, cache, and database. The server returns a response with HTML, CSS, JavaScript, or data. The browser parses it, fetches dependencies, builds the DOM, and renders the page. Make sure to cover DNS resolution, TCP handshake, TLS negotiation, HTTP request response flow, load balancers, application servers, databases, caching, and how the response is rendered by the browser. Question 3. How do you investigate high CPU usage on a production server? High CPU is a symptom, not the root cause. I first use top or htop to identify the process. Then PIDstat, PS, or perf if deeper analysis is needed. I check whether CPU is user, system, I/O wait, or steal time. Then I correlate with traffic spikes, cron jobs, recent releases, or runaway threads. If it is production, I capture evidence before restarting anything, because restarts can hide the real issue. In your answer, talk about identifying the offending process, checking threads, understanding user versus system CPU, correlating with traffic, logs, deployments, and avoiding disruptive commands in production. Question 4. Explain the difference between TCP and UDP. When would you use each? TCP is connection-oriented and provides reliable, ordered delivery using acknowledgements, retransmissions, and flow control. I use it for SSH, HTTPS, databases, and anything where correctness matters. UDP is connectionless, has lower overhead, and does not guarantee delivery or ordering. It fits DNS, VoIP, gaming, and streaming, where speed matters more than perfect reliability. The choice depends on whether the application prefers guaranteed delivery or lower latency. Be sure to mention connection-oriented versus connectionless behavior, reliability, ordering, retransmission, latency, overhead, common protocols, and examples like HTTP, SSH, DNS, streaming, and gaming. Question 5. How would you design a basic monitoring and alerting strategy for critical infrastructure? I monitor from both the system and user perspective. For infrastructure, I track CPU, memory, disk, network, process health, and service availability. For applications, I focus on latency, error rate, throughput, and saturation. Alerts should map to user impact or SIO risk, not every minor metric change. I also create dashboards, runbooks, escalation policies, and post-incident reviews. Good monitoring reduces mean time to detect and mean time to recover. While answering, cover metrics, logs, traces, health checks, alert thresholds, SLOs, dashboards, escalation paths, noise reduction, runbooks, and monitoring both infrastructure and user-facing symptoms. Question 6. What is DNS, and how would you troubleshoot a DNS resolution failure? DNS translates human-readable names into IP addresses using records like AAAA, CNAME, MX, and TXT. To troubleshoot, I check local resolution with dig or NSLOOKUP. Verify/btcresolve.conf. test against public resolvers, and query authoritative name servers directly. I also check TTL, recent record changes, DNSSEC issues, and internal versus external DNS views. A common mistake is blaming propagation when the real problem is cached stale data or wrong resolver configuration. Make sure to cover record types, recursive and authoritative resolvers, TTL, caching, tools like dig and NSLOOKUP, local resolver configuration, propagation delays, and split horizon DNS issues. Question 7. How do you handle disk space issues on a Linux server? First, I confirm whether the problem is space or inodes using df-h and df-i. Then I locate large directories with du and check logs, temporary files, backups, and application data. If space is still missing, I look for deleted files held open by processes using LSOF. I avoid deleting unknown files blindly. After recovery, I add log rotation, retention rules, monitoring, and capacity alerts so the issue does not repeat. In your answer, discuss identifying full file systems, inode exhaustion, log growth, deleted but open files, safe cleanup, retention policies, alerting, and preventing recurrence through automation. Question 8. What is load balancing, and what are common load balancing algorithms? Load balancing spreads traffic across multiple back-end servers to improve availability, performance, and fault tolerance. Common algorithms include round-robin, least connections, weighted round-robin, IP hash, and latency-based routing. Layer 4 load balancers route using TCP or UDP information, while Layer 7 load balancers inspect HTTP details like path or headers. I also care about health checks, connection draining, and session persistence. A load balancer helps scale, but it must be highly available too. Be sure to mention distributing traffic, health checks, Layer 4 versus Layer 7 balancing, round-robin, least connections, weighted routing, session persistence, failover, and scaling benefits. Question 9. How would you automate repetitive systems administration tasks? I automate tasks that are repetitive, error-prone, or need consistency across many machines. For simple local tasks, Bash may be enough. For richer logic, I use Python. For configuration management, I prefer Ansible, Puppet, or Chef. And for infrastructure provisioning, Terraform is common. The key is idempotency. Running automation twice should not break anything. I store code in version control, test changes safely, handle secrets carefully, and document rollback steps. While answering, focus on scripting, configuration management, idempotency, version control, testing, secrets handling, rollback strategy, CI/CD integration, documentation, and choosing tools like Bash, Python, Ansible, or Terraform. Question 10. What steps would you take if a service is down, but the server is reachable? If the host is reachable, I check the service status with systemctl, then verify whether it is listening on the expected port using SS or netstat. Next, I review service logs, dependency health, configuration files, certificates, permissions, and recent changes. I also check resource pressure and firewall rules. If a restart is safe, I capture logs first, restart, and watch metrics. During an incident, I communicate impact, actions, and ETA clearly. Make sure to cover checking service status, ports, logs, dependencies, configuration changes, resource exhaustion, firewall rules, recent deployments, restart strategy, and communicating incident status clearly. Question 11. Explain RAID levels and where you would use them. RAID combines disks for performance, redundancy, or both. RAID 0 stripes data for speed, but has no redundancy. RAID 1 mirrors disks and is simple to recover. RAID 5 uses single parity, RAID 6 uses double parity, and RAID 10 combines mirroring and striping for strong performance and resilience. I choose based on workload, capacity, and rebuild risk. Most importantly, RAID protects against disk failure, but it does not replace backups. In your answer, discuss striping, mirroring, parity, performance, redundancy, usable capacity, rebuild risk, RAID 0, 1, 5, 6, 10, and why RAID is not a backup. Question 12. How do you secure a Linux server before putting it into production? I start with a minimal install and enable only required services. I patch the system, configure firewalls, disable password-based SSH, restrict root login, and use key-based access with least privilege. I review users, sudo rules, file permissions, and open ports. I also enable logging, audit policies, time synchronization, backups, and vulnerability scanning. Secrets should not live in plain text configs. Security is not one setup task. It needs continuous review. Be sure to mention least privilege, SSH hardening, patching, firewall rules, service minimization, user access, logging, file permissions, vulnerability scanning, backups, and secrets management. Question 13. What is the difference between virtualization and containerization? Virtualization runs full guest operating systems on a hypervisor, so each VM has strong isolation but higher resource overhead. Containers share the host kernel and package the application with its dependencies, making them lightweight and fast to start. I use VMs when I need stronger isolation or different operating systems. I use containers for portable application deployment and scaling. Containers are efficient, but kernel sharing means security boundaries must be designed carefully. While answering, compare hypervisors and guest operating systems with containers sharing the host kernel, isolation level, startup speed, resource overhead, portability, and use cases for each. Question 14. How would you plan capacity for a growing production environment? Capacity planning starts with data, not guesswork. I review historical CPU, memory, disk, network, request volume, latency, and error trends. Then I estimate growth, peak traffic, seasonal events, and failure scenarios like losing one node. I define headroom targets and validate assumptions with load testing. The plan should include scaling triggers, budget impact, and procurement or cloud provisioning timelines. Good capacity planning prevents both outages and waste. Make sure to discuss historical metrics, traffic forecasts, peak usage, growth rates, headroom, bottlenecks, load testing, cost trade-offs, scaling strategy, and capacity alerts. Question 15. Describe how you would manage a production incident from detection to resolution. During an incident, I first confirm impact and severity, then assign roles, incident lead, communicator, and technical responders. The immediate goal is mitigation, not perfect root cause analysis. I check dashboards, logs, recent changes, and dependencies, then decide whether to roll back, fail over, scale, or disable a feature. I keep stakeholders updated with facts. After recovery, I document the timeline, root cause, lessons learned, and concrete prevention tasks. In your answer, cover triage, severity, communication, assigning roles, mitigation versus root cause, rollback, monitoring recovery, timeline capture, postmortem, action items, and preventing repeat incidents. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.